Alright, today we are going to be learning about graphing quadratic inequalities. And the first thing we want to be able to figure out is a point a solution to the inequality? And it does say to show our work. So what we're doing is we're going to be testing to see if this particular point, point 2, negative 1, is a solution to this inequality. There's two ways you can do this, but the way that we're going to use to show our work is doing this algebraically. So in this point, 2, negative 1, 2 is our x and negative 1 is our y. That means everywhere we see an x here, we're going to plug in 2. And everywhere we see a y, we're going to plug in negative 1. So we would have negative 1 is less than 2 squared minus 3 times 2 plus 7. And when you calculate this on the right-hand side, we get negative 1 is less than 5. And we're going to see if that is a true statement. And in fact, negative 1 is less than 5. So this is a true statement, and we would say that 2, negative 1 is a solution. So with each of these questions, as long as they ask you if something is a solution or not, then you would plug in those numbers. So let's look at a second example here. We have y is greater than 2x squared plus 3x minus 6. And now we're going to be testing if the point negative 2, negative 4 is a solution for that inequality. Again, x, comma, y. So we're taking those numbers and plugging them in for the different variables in which they represent. When we do this, we get negative 4 is greater than negative 4. And since it doesn't have the equal to piece there, that is not a true statement. So we would say negative 2, negative 4 is not a solution. You could also do this by looking at a graph. If those points were in the shaded region of the graph, that it would be fine. If they weren't in the shaded region, then they would not be solutions as well. So we have three basic steps for graphing quadratic inequalities. The first is to plot the points for the quadratic. That kind of depends on if it's in standard form or in vertex form. Depending on which one, you'll have a different number of points. The next thing is to determine solid or dashed. So let's talk about that for a second. If we have less than or equal to or greater than or equal to, those two, back when we did linear inequalities, would give us a solid line. Okay, so now we're going to have a solid parabola. If we have just less than or just greater than, those would produce a dashed line for us. Okay? After we determine whether it's solid or dashed, we're then going to determine if we are going to shade inside or outside, above or below each of those parabolas. Okay? So for our examples today, you're going to actually be using this sheet that I gave you. I'm going to choose a few of these to actually go through and graph with you all. Okay? So the first one we're going to look at is number 1. So here we have y is less than negative x squared plus 2x plus 3. And so since this is in standard form, we would have to do our steps to find the vertex. So that means that we'd have to have the opposite of b over 2 times a. And calculating that math, negative 2 divided by negative 2 would give us 1. Once we have that value, we can plug it back in to figure out what our y value is for the vertex. And doing that math, we get 4. That means that we're going to create our table, and we need 5 points in the table. Our vertex is the center point. 1, 4 is that vertex we just produced. We need to go 2 spaces up and down. It doesn't matter which way you go first. And then we're plugging in those values to figure out the y-coordinates. So in plugging these in, we will get 0, 3, 4, 3, and 0. And remember, we should have that nice pattern going on here. So that's good to go. All right, we're plotting those points. And we do notice that the original inequality has a negative a value, which means when we graph this, it should be facing down, which it is. And this is not equal to, so we're going to dash in our parabola. And we're going to do the best that we can in order to make sure that it stays a U and that we're extending that graph all the way out. Now, y is less than negative x squared plus 2x plus 3. That means we're thinking to ourselves, if we're somewhere on this graph and we want to be less than, would we be down here inside of the parabola or would we be outside? Well, less than makes us think below, so we're actually going to be inside the parabola. Any point inside this parabola shape would be a solution. Now, you're asking yourself, would this point here, 3, 0, be a solution? Well, it's on a dashed line, so remember that means that would not be a solution. Anything on this parabola would not be a solution to this quadratic inequality. Let's take a look at another example. Here we have y is less than or equal to 2x squared minus 8x plus 9. So again, it's in standard form, which means we're going to find the x coordinate of our vertex by using the opposite of b over 2 times a. And that would give us an x value of 2. Plugging that back into the original equation and completing the math is going to give us a y value of positive 1. We create our table with our vertex in the center. 2, 1 is the vertex. And again, we go 2 spaces up and 2 spaces down from that x coordinate of 2. So when we plug in those values, plugging in 0 gives us 9, plugging in 1 gives us 3, plugging in 3 gives us 3, and plugging in 4 gives us 9. So we're going to plot those points on our graph. Since our a value is positive here, it should be facing upward. There is an equal to piece to this, which means we will have a solid line when we connect these. Last thing to do is to figure out where we're going to be shading. So it says y is less than or equal to. So again, if we're somewhere on this parabola, where would we be less than? That's going to be anywhere outside of this parabola. An easy point to focus on is the vertex. So if it's greater than, you're going to be above the vertex. If it's less than, you're going to be below the vertex in your shading. The other 2 questions that we're going to complete are going to be ones that are in vertex form. So these are a lot easier and faster to graph because there's only 2 things that we have to find first. So if we have y is greater than or equal to negative 1 times the quantity x plus 4 squared minus 4, our vertex is going to be the point negative 4, because we switched the sign of the value inside the parentheses with x, and whatever's added or subtracted outside we keep the same. Our a value is what's in front, so again I said that negative 1 before. That means our a, our slope, is negative 1 over 1. So we plot that vertex negative 4, negative 4. And then our slope is down 1, right 1. You can also go down 1, left 1 as well because we know that a parabola is symmetric. Now, it does make sense that it faces down. Here we have y is greater than, or equal to. So since it's equal to, we're going to make this be a solid parabola facing down. And it says y is greater than, so if we're focused on that vertex, greater than would be any of these points higher than that vertex, or on the outside of that parabola facing down. We're going to do one last example here in vertex form. So we have y is greater than the quantity x minus 3 squared plus 2. Again, in vertex form, you need 2 things to be able to graph. Our vertex here, switching the sign of the negative 3 inside, becomes positive 3, and the 2 on the outside stays the same. Our a value up front, there's a 1 there, so our quote slope is 1 over 1. Plotting the vertex, we have 3, 2. Counting our slope, we're going to go up 1, right 1, or up 1, left 1. Both of those work. Since it is just greater than, we're going to have a dashed parabola here. And since it is y is greater than, We're focused on this vertex. If we want to be greater than, we would be inside the parabola there. So that would be your solution.